Hi guys, let's look at the next exercise 17b. But before we start, let's quickly revise certain properties that we've done in class 9. The first one, it says if arc APB is equal to arc CQD, then if these two arcs are equal, then the angle that they subtend at the center is equal, which means angle AOB and angle COD would be equal. So if arcs are equal, then the angles subtended at the center are also equal. Similarly, if one arc, the length of one arc is 3 times the length of the other arc, then the measure of the angle at the center would be 3 times the measure of the angle at the center of the other arc. Similarly, if the arcs are in a certain ratio, in this case 7:11, then the angle subtended at the center would be in the ratio 7:11, which is the same ratio. Next, in case we inscribe a equilateral triangle, not just equilateral, any regular polygon, which means a polygon where all sides are equal and all internal angles are equal, then if we inscribe such a regular polygon in a circle, then the angle subtended at the center is given by the formula 360 degree upon n. So in this case, since this is a triangle, which means n is equal to 3, which means each angle subtended by the side at the center would be 120 degree. So AC subtends an angle of 120, similarly AB, similarly BC. Let's look at the next one. The next one says, which is what we've done in the previous slide also, but just want to highlight, if two chords subtend equal angles, which means if angle AOB is given equal to angle COD. So if two chords are subtending equal angles, then the arcs are equal, which means arc APB is equal to arc CQD. This can also be read as chord AB is equal to chord CD. So arcs are equal, then chords are also equal. The converse of this would be if two arcs are equal, which means what is given is if arc APB is equal to arc DQC. If the arcs are equal, then the angle that they subtend at the center would be equal. That's the one that we did in the previous slide as well. Now that we've revised this, plus we already know the 5 new ones that we learned this year, let's go ahead and solve some questions from the exercise. So let's look at the first question that we solved, which is question number 2. It says AD is a diameter, O is the center, so this is center O. Chords AB, BC and CD are equal, which I have marked here. Angle DEF is equal to 110 degree. We need to find angle AEF. AEF not given, let's just draw it. So let's first join AEF. So I need to find this angle. Now as soon as I see a diameter in a circle, then the first thing that comes to my mind is an angle formed in a semicircle is right angle. So in this case, this angle is 90, the total angle is 110, which means this remaining angle is 20 degree. Let's just write whatever we've done till now. So first thing, join AE. Next, angle AED is equal to 90 degree, angle in a semicircle. Next, angle AEF is equal to 110 degree minus 90 degree, which means angle AEF is equal to 20 degree. So the first part of our question done. Let's look at angle FAB. So where's angle FAB? So I need to find this big angle. Okay, let's see if I can find something which will help me get this big angle. Okay, since these three sides are given equal, which means the angle that they subtend at the center would definitely be equal. Which means if this is x, this is also x, this is also x. So 3x would be equal to 180, which means each angle here is 60 degree. Let's just write that down. Number 5. Since AB is equal to BC is equal to CD, therefore equal arcs subtend equal angle at the center, which means angle AOB is equal to angle BOC is equal to angle COD is equal to x. In this case, angle AOD is equal to 180 degree is equal to 3x, which means x is equal to 60 degree, which means in triangle AOB, angle AOB is equal to 60 degree and OA is equal to OB. Reason is these are radii of the same circle. So radii of same circle, which means angle OAB would be equal to angle OBA, which would be, if I'm looking at triangle AOB, it will be equal to 180 degree minus the angle which is known to us, which is 60 degree divided by 2, which means this angle is 60 degree, which means it's basically an equilateral triangle. So I have 60 degree here. I still need to find this angle. Now if I look at cyclic quadrilateral AFED, if angle E is 110, then this angle is 70 degree because sum of opposite angles in a cyclic quadrilateral is 180 degree. So in cyclic quadrilateral AFED, angle FAD plus angle FED is equal to 180 degree, which means angle FAD is equal to 180 degree minus 110 degree is equal to 70 degree. So angle FAB would be equal to angle FAD plus angle BAD, which is 70 degree plus 60 degree. So this is equal to 130 degree. That's the second part of the question which we've done. Interesting question. Let's move on. The next question that we are solving is question number 4. Let's read the question. Question says, circle with center O, PQ is equal to QR is equal to RS, and angle PTS is equal to 75 degree. We need to calculate angle POS. So let's just first join angle PO and SO. Now in this triangle, this is definitely not a straight line. So the angle at the center would be double the angle at the circumference, which means this would be 150 degree. Next, so this part is done, QOR. So let's just join QO and RO. Since this is the reverse of the other one, since these are equal chords, which means they subtend equal angle at the center. So this is 3x, which is equal to 150 degree, which means this is equal to 50 degree. This is also 50 degree, and this is 50 degree. We need to calculate QOR. So we have calculated QOR, it is 50 degree. Next part of the question, QOR. Yeah, QOR is 50 degree, done. Next part of the question, PQR. So PQR, for that I need to find this angle and I need to find this angle. Let's just first write whatever we've done. So number 1, angle POS is equal to 2 times angle PTS. Angle at center is equal to 2 times angle at circumference, which means angle POS is equal to 150 degree. First part of the question done. Let's look at the second part. Number 3, since PQ is equal to QR is equal to RS, therefore equal chords subtend equal angle at the center. What it means is angle POQ is equal to angle QOR is equal to angle ROS is equal to X. Point number 5, angle POS is equal to 3x is equal to 150 degree, which means x is equal to 50 degree, which means angle QOR is equal to 50 degree. So the second part of the question is also done. Now we need to come to the third part. So if I look at this triangle POQ, PO and OQ are equal because these are radii of the same circle. So if this is 50, this is an isosceles triangle, which means these two angles are equal. The sum of which is 180, which means 180 minus 50, that's 130. So this angle is 65. Similarly, this angle is 65. In this triangle QOR, these two sides are equal. OQ and OR are equal, which means this is also 65 degree and this is also 65 degree. So angle PQR would be 130 degree. Let's just write this down. Number 7. In triangle POQ, OP is equal to OQ, radii of same circle, which means triangle POQ is isosceles, which means angle OPQ is equal to angle OQP, which is equal to 180 degree minus 50 degree upon 2, which is equal to 65 degree. Next, in triangle QOR, OQ is equal to OR, again radii of the same circle, which means triangle QOR is isosceles, which means angle OQR is equal to angle ORQ is equal to 180 degree minus 50 degree upon 2, which is equal to 65 degree. And angle PQR is equal to angle OQP plus angle OQR, which is equal to 65 degree plus 65 degree. So this is equal to 130 degree. So that's the last part of the question, which is also done. Let's look at the next question. The next question that we do is question number 5. Question number 5 says, AB is the side of a regular hexagon. AC is the side of a regular octagon. The center is O. We need to find AOB, this angle. So this one is simple. We know that the angle subtended by a regular polygon is equal to 360 degree upon number of sides. So angle AOB would be equal to 360 degree upon hexagon would mean 6 sides. So this is equal to 60 degree. So this angle is 60 degree. First part of the question done. Next, angle ACB. So angle ACB would be half of angle AOB. This is the angle subtended at the center. So this would be angle subtended at the circumference would be half of it. So point 2, angle ACB is equal to half of angle AOB. So this would be equal to 30 degree. Reason, angle at center is equal to 2 times angle at circumference. So the second part of the question also done. Let's look at the third part. The third part is angle ABC. So I need to find this angle. So angle ABC would be half of angle AOC. So let's just join O and C. So join OC. Next, angle AOC would be 360 degree. In this case, it's a 8-sided octagon, 8-sided, which means 8. So this angle is equal to 45 degree. We know, we just spoke about it, which is angle ABC would be half of angle AOC. This is 45 degree. So this would be equal to 22.5 degree. This is 22.5 degree. Reason, again the same, angle at center is equal to 2 times angle at circumference. So angle at center is equal to 2 times angle at circumference. Good. So that finishes this question. That finishes this video also for me. Let me mark any homework questions. No homework questions for you. Thank you so much. Take care. Be safe. I'll see you with the next video. Bye bye.